Hello, am I audible? Am I audible? आवाज येतोय का? हॅलो.
हो येतोय.
ओके. All right. Let us now talk about equations of initial value problems. How to solve initial value problems. So the question in front of us is from the previous question paper. Question says y dash is equal to matrix times y given y of 0 equal to this column matrix. And question carries 5 marks. So what we do is we read this equation as y dash is equal to ay. It is y dash is equal to ay, and matrix is a 2 by 2 matrix with a row 2 4 and the second row as 4 2. So what we need to do is very first we need to find the eigenvalues and then we find the eigenvectors of matrix A. For the same, as you know, we need the characteristic equation. How is the characteristic equation? It is the determinant of the matrix lambda I minus A equal to 0. I meaning identity matrix. So how do we construct lambda I minus A? Are you familiar? Lambda in bracket you have 1 0 0 1, and from that you are subtracting your original matrix 2 4 4 2. Sorry, 2 4 4 2. I hope you got it. So what will be those entries? This will be lambda into 1 minus 2. So it is lambda minus 2. Next, here being 0, you are just writing minus 4. Here also minus 4, and this entry will be lambda minus 2. So what you need to keep in mind is along the diagonal you will be having lambda minus the entries, and all the remaining entries are simply negated. Fine?
Yes.
And then you find its determinant and equate it to 0. So this becomes lambda minus 2 bracket square minus product of minus 4 into minus 4, that is 16, equal to 0. You simplify this. So what you got is lambda square minus 4 lambda minus 12 equal to 0. You factorize this minus 12. This being minus, the factors will have opposite sign. And their sum should be minus 4. So the bigger one should be negative. So 6 and 2. Bigger one, let us have minus, and the smaller one, let us have with plus sign. So what you got is lambda equal to, yes,
6 and minus
6 and minus 2. So these are the eigenvalues. And now you go for the eigenvectors. So you can see on the board itself. So to find the eigenvectors, what do? We solve this kind of system. That lambda I minus a matrix multiplied by this equal to zeros means we solve homogeneous system. These are the variables. It being 2 by 2, we'll have two variables over here. So put lambda equal to 6. So lambda I minus a becomes 4 minus 4 minus 4 4. And you go on performing row operations. So what you'll do is you'll add this first row to the second row. So second row becomes 0 row. So ultimately you are having 0 row. And then you'll multiply this particular first row by 1 by 4. So that gives you 1 minus 1. Got my point?
Yes.
So I think I need not show it to you. Hmm? So two row operations we performed and we are reaching to this kind of matrix which we call as a row echelon form of matrix. Now how would you solve this? Rewrite the equation. So this is first variable x1, 1 times x1 plus minus 1 times x2 equal to 0. This is the equation. So what it gives you, x1 is equal to x2. Followed? We rewrite this equation. These are the coefficients. First column stands for first variable, second column stands for second variable. What are the variables you are watching here? x1 and x2. Followed?
Yes. Yes.
Okay. So you rewrite the equation, it becomes x1 minus x2 equal to 0, meaning x1 is equal to x2. Now, coming back to this particular matrix, it is row echelon form of a matrix. So you know this entry, what you call it as leading one. This is a leading one in the first row, but second row doesn't have leading one. There is no leading one in the second row. So the second variable is free. So it being free, we can call x2 at some value t, some real number t. I can say some real number t. So this is t. Okay. Now, if I put x2 is equal to t, what will be the value of x1 automatically? X1 will also be t.
T.
Yes, so x1 is also t. So what is your solution then? So x1, x2, this was your matrix, column matrix. So what will be the value? Oh, just a minute. I would like to go back here. So the matrix I got is x1, x2 and equal to, it becomes t, t. First entry t, second entry t. What is t? T is any real number, arbitrary real number, and let me take t common. What I'm left inside with?
1 1.
Yes. So last year you used to find out the basis. So 1 1 is the vector which we call as eigenvector. So you can see we have written over here very directly eigenvector for lambda equal to 6 is 1 1. Got it?
Yes.
Okay. Now I would like to move for lambda equal to minus 2. Same way we did it now. So we are going for lambda equal to minus 2. So again we go with lambda I minus a. This will be minus 2 minus 2. This is minus 4 and the same way. So I got all the entries to be minus 4. Again by row echelon, this should be equivalent, not equal. This is equivalent. So what is going to happen? R2 minus R1 will give me second row to be 0 row. है ना? I
Yes.
subtract first row from the second row. What we call it as R2 minus R1. So what it produces? Second row to be 0 row. Now first row is minus 4 only. We multiply by minus 1 by 4. It gives us 1 1. Okay.
Yeah.
Then we rewrite the equation. It becomes x1 plus x2 equal to 0. You know, the first column stands for first variable x1. So it is 1x1 and this is 1x2 and sum is equal to 0, meaning x1 is equal to minus x2. Again, our first variable is leading variable, but there is no leading variable for the second column. So you put x2 is equal to t. So what will be x1? It will be minus t. So what will be your matrix? Matrix will be minus tt. Again, you'll take t common. What you're left inside with is column matrix minus 1, 1, which we have written over here. So it is the eigenvector for lambda equal to minus 2. Got the thing?
Yes.
Okay. Now have to write the solution that we are watching. Have to write the solution. So let us rub this. Yes, now you can watch it very clearly. So what you observe? Your solution is C1 times Y1 plus C2 times Y2. What is Y1? The eigenvector you got multiplied by e raised to eigenvalue times t. What is your solution? Y1 means column matrix means the eigenvector times e raised to eigenvalue. Same kind of thing you used to do in dynamical systems if you remember. And Y2 is also having the same kind of thing. It's eigenvector multiplied by e raised to eigenvalue times t. And as usual, we multiply them by arbitrary constants C1 and C2. Fine?
Yes.
Okay. Now, because it is initial value problem, they have given us initial condition to calculate the value of C1 and C2. So what you observe here, for calculating C1 and C2, they have given us y of 0 equal to this matrix. Y of 0 means what? When the independent variable has value 0, output is this. So we have put t at 0. If we put t equal to 0, what do we get? C1 into column matrix 1, 1 plus C2 into column matrix minus 1, 1 because e raised to 0 is 1 and right side will be the value 5 minus 1. So we got two equations in two unknowns. First, have to add. So C1 times 1 plus C2 times minus 1 means C1 minus C2 is 5. C1 plus C2 is minus 1. So what are the values? Twice C1 becomes 4. C1 is 2. C2 is minus 3. And what will be the solution then? You just put the values of C1, C2 there. So that is your solution. Have you got it?
Yes.
Okay. Now what this means? So Y means what? It has two entries over there. It is a column matrix. First entry we call as Y1, second entry we call as Y2. So the first row, let us read. So first row will be Y1 is equal to, this will be twice e raised to 60 minus 3 into minus 1 making plus 3 e raised to minus 2t. Can you read this? Okay, let me go back here. All right. You can see Y means what? It has two entries. The upper one is Y1 and the second entry is Y2. This is the column matrix Y1, Y2 means Y and is equal to this particular. So what we'll do is when I'm reading Y1, I'll read the first row. So Y1 is equal to twice 1 into e raised to 60. So I got 2 e raised to 60. Got it?
Yeah.
Then minus 3 into minus 1 makes it plus 3 into e raised to minus 2t. That is what we have written. Is it fine?
Yes.
And going with the second row, you can say 2 into 1 e raised to 60 I have written. Minus 3 into 1 means minus 3 e raised to minus 2t. So we got two equations separately. This is the solution. Okay.
Okay.
Now I would like to move to similar kind of question. Only the fact is it is not initial value. It is general solution. and I have taken 3 by 3. See, find the general solution of y dash is equal to this matrix times y. It's a 3 by 3 one. So you can see A is this matrix. We find its characteristic equation as usual. You are quite familiar with this particular. So we go with determinant of lambda I minus A equal to 0. As I have said, we introduce lambda diagonally and every entry of A is negated. So you can watch it. And this determinant is equal to 0. Okay.
Yes.
Okay. Then we solve this determinant. So lambda plus 3 times this product minus this product that I have written. Then minus of minus 2 here times this minus 2 into lambda plus 3 I have written minus this product I have written. Then it is minus 2 this entry. In bracket you can see this product plus 4 and minus 2 times this. So it becomes plus 2 times lambda plus 3. If I simplify this, I think you can go through this. I get this polynomial equation. I got lambda cube plus 9 lambda square plus 15 lambda minus 25 is equal to 0. So what I did was I just saw if I add all the coefficients, do I get a 0? See, 1 plus 9 is 10, 10 plus 15 is 25, minus 25 makes it 0, means 1 is the root. 1 is the root. So I got 1. By synthetic division, Samshleshak Bhagakar Paddhati, by synthetic division method, I wrote the coefficient from here, coefficient of cube, coefficient of square, coefficient of linear, and a constant. 1 taken down, 1 one's a 1, I have written. I add this, I got 10. Again 10 one's a, I wrote here, I add, it is 25. Now 25 ones are 25. I add, the answer is 0. Once I get 0 as a remainder here, you can see the division is successful division, full division. And what we are getting is this is lambda square plus 10 lambda plus 25. So this is the factorization we got. Now this is complete square, so I wrote lambda plus 5 bracket square is equal to 0 and one factor was already lambda minus 1 due to this one. Okay, so what are the values of lambda? 1 minus 5 repeated minus 5. Got it?
Yes.
Okay, these are the eigenvalues of A. Now we need to find the eigenvectors. For that we solve this homogeneous system. Lambda I minus A into X is equal to 0. Equal to 0 means homogeneous. Now this is the system with us. We have to put the values of lambda here. Solve it by Gaussian or whatever method you know. And whatever you get is the eigenvector corresponding to this value. So you can check here. I have put lambda is equal to minus 5 in the beginning. I got this kind of thing. All entries are minus 2. So very directly you subtract the first row from the lower rows so that you'll get 0 rows. And in the first, you just multiply by minus 1/2. So that gives you 1, 1, 1. Followed? If we have same entry and if we subtract, obviously we are going to get 0. What was the operation used over here? R2 minus R1
R1.
and same way R3 minus R1. So that gives me 0 rows over here. And the upper row you can see is minus 2, minus 2, minus 2. For that, I can use minus 1/2 R1. So if I go with this, what will happen? I'll get 1, 1, 1. Followed?
Oh.
If I multiply by minus 1/2, 2 minus 2, what do I get? 1. Same here and same here. Got it now?
Yes.
And to this, you are multiplying by minus half. So what it gives you? 1, 1, 1. Okay?
Yes.
All right. Then we rewrite the equation. We rewrite. So what is the equation with us? X1 plus X2 plus X3 equal to 0. Means what? X1 is equal to minus X2 minus X3. How are X2 and X3? They don't have leading one in their column. So they are free. They being free, you can call them as T, R, S, something like that. And what happens is X1 will be then negative of X2. So this place is minus 1. Place of X2 will be 1. And at that time, place of X3 we put 0 because they are independent of each other. And talking of this particular X1 again is negation of X3. So in this place it is minus 1. X2 will be written in 0 and this will be 1. If you want, you can go like this also. I would like to, yes. So let me go here. See, I put X2 as some T and X3 as S. So what will be X1? Minus T
minus
minus S. What will be our matrix then? Matrix will be minus T minus S. Place of X2 I'll write T. Place of X3 I'll write S. Now you separate this in terms of T's and S. So this is minus T, T, 0. I hope you remember this we have done in dynamical. Plus this will be minus S, 0, S. We have separated T and S. Followed this? Have we done this way?
yes.
Okay. And what you observe next is the same we
Minus
can write as T taken common. Inside we are getting minus 1, 1, 0 and plus here S taken common,
plus 1.
minus 1, 0, 1. So we have written these two vectors as you are watching. Okay.
Yes.
And both are linearly independent because at a time you are getting both the vectors. So they are linearly independent. So what are the solutions with you? So first solution y1 you can write as first vector into e raised to minus 5t. And the second solution you can write as second vector times e raised to minus 5t. Fine. Always how we write it? We write the eigenvector into e raised to eigenvalue times t. So that is why we got two solutions. Got my point?
Both are y1 solution, na?
Yeah, we have got two solutions here. We have got two solutions because we got two eigenvectors. First solution we are calling as y1, second solution we are calling as y2. We are having three variables with us, so we have three solutions. And third solution will be got by putting the third eigenvalue. You know, one eigenvalue was repeating. Minus 5 was repeating. So we got two values for minus 5. And now we have to deal with lambda equal to 1. So we will do it. Is it?
Yes.
Okay. So you can see we put lambda equal to 1. We got this kind of matrix. I hope you'll go through this. And if I simplify, I come to this kind of row echelon form. I rewrite the equation. This becomes x1 minus x3 equal to 0 and x2 minus x3 equal to 0. So what this gives me x1 equal to x3 and x2 equal to x3. And if I simplify, both are equal to same variable x3, means all three are equal. Okay. Got my
Okay.
point?
Yes.
All three being equal, this will be 1, 1, 1. And the solution will be y3 is equal to this eigenvector times e raised to 1t. And now the general solution will be the sum of these three, है ना? Linear combination. So we take arbitrary constant C1 times our first solution plus C2 times second solution plus C3 times third solution. Got it?
Yes.
So I think it is very easy. You can go with such kind of things. You need to solve. I would like to suggest you. See, I have marked the chapter, the content in your textbook there. You can visit our Google Classroom book I have shared to you, and you can go through. Just find out such kind of questions and try to solve it, at least from the previous question papers. Okay?
Okay.
All right. And one more thing I want to share with you. This is one thing, and another one is this one. This also you can find out over there. Let me expand. See, this kind of equation is always supplied to us. The coefficient of y double dash we call as p naught of x. Y dash, its coefficient is p1 of x, and the coefficient of y is p2 of x. I think in our previous lecture we mentioned it. I could not record it. The recording was not finished there, so I cannot supply it to you. But I think you remember.
Hmm.
Okay?
Yes.
Now, you see, this p naught of x, wherever it is 0, that point we call as singular point. The point where this coefficient becomes 0 is called singular point. Now, the singular point is of two types, regular singular and irregular singular. So, how to define regular singular? So, see, if x naught value is a regular singular point, then what you find? This equation will be of the type x minus x naught bracket square times a of x, something, where this a of x naught is not a 0. I repeat, if x naught is singular point, then this particular will be of this pattern x minus x naught bracket square into something, and that something should not vanish. Then that point is called as a regular singular point. And if this happens to be 0, it is called irregular singular point. So my suggestion to you is just take down this definition. If it is asked, it will be for 1 mark. If not asked, they might ask you, find out the singular point and what kind of singular point it is. So one question just now, I think I told you, talking of Bessel's equation. X square y double dash plus xy dash plus this equal to 0 is called Bessel's equation. What you find here? This is x minus what bracket square? It is x minus 0 bracket square. Or you can say x square equal to 0 if I put. What is the value of x? Value of x is 0. So that point is x naught is equal to 0. Now what kind of singular point it is? So x square multiplied by what? There is nothing, means there is 1. Is it non-zero? Yes. A of x is 1. It is non-zero. So this point is a regular singular point. Got it?
Yes.
Now, Legender's equation, if you see, it is 1 minus x square times y double dash. There are 3 equations in your syllabus. So you must by heart this. Now, if you read this equation, you can see 1 minus x square becomes 0 at plus 1 or minus 1. And what is the coefficient here? If I write this as x minus 1 bracket square, what happens? This is x plus 1 with it. And x plus 1, does it vanish at 1? No, it becomes 2, 1 plus 1. So it is a regular singular point. Same way, you can put x naught equal to minus 1 also. What you need to do is you need to arrange this equation in this pattern. You need to write it in this pattern. So for that, you need to multiply by something, whatever is required. Rearrange the equation. You are multiplying it throughout. Here it was 1 minus x square. So what you did, 1 minus x square, you can write as 1 minus x into 1 plus x. So that is what they have rearranged it. Fine?
Yes.
Okay. Now I move to one more kind of thing. This is another equation. I think I missed it. Yes, yeah. X cube y double dash plus xy dash plus y equal to 0. So what you observe, there is x cube. If I put x cube equal to 0, I get x equal to 0. So 0 is our singular point. But is it regular? So you can write this equation as what? X square into x into y double dash. So x square into x. So there is 0 there. So it cannot be regular. So it becomes irregular. Got my point?
Yes.
Okay. We can write it as x square into x and then y double dash. So this x will be 0. So it cannot be regular. It becomes irregular. Okay? So I think this is sufficient for today. I would like to share those slides, 2-3 slides with you. Okay? Keep studying. And I don't think there is any kind of jumbling. You know better the things. Am I correct?
Hmm.
Yes?
Yes.
So I hope you'll do it properly. I think the recording is okay. So I'll share this recording to you so that you can revisit it and check. And the slides and the screenshots are already with you. Okay?
Sharing on YouTube.
I'll share these 5 slides.
Oh,
Okay?
okay.
So for today, let us stop. Keep studying. Hmm?